twice of the length 0 to pi by 2. T is pi by 2 or theta is pi by 2, sorry, yeah, theta is pi by 2. From 0 to pi by 2 length if I take, and it was 4a, we have already calculated. It was 4a into sin psi we have taken. Here psi angle is from 0 to the pi by 2. Okay, if I take psi or if I take half theta, then it is 0 to pi by 2. Undoubtedly, we have to integrate this then. So it will give us sine half of pi theta, and then it will. So let me take this length of the curve and make twice of that, because this is 0 to pi by 2. Total length of the cycloid. The length of the cycloid. Total length of the cycloid is s equal to twice of 0 to pi by 2 limit 4a sin psi. Okay, so if I just integrate this is d psi. If I have taken psi angle, then 0 is, this is 0 to psi angle here. Okay, 0 to psi angle we have to take. So in this case, the length here, if I have to find out total length, the intrinsic equation of the cycloid, this is theta equal to 0 to theta equal to pi. If I take cusp at theta equal to pi, and then twice of that. Okay, so that will give us 0 to pi angle, and the cusp. Okay, at the okay, from first at the vertex psi equal to 0 to, and at the cusp, here it is the vertex and the cusp, the same thing. Okay, so we have taken at the cusp theta equal to, I'm sorry, here theta is, at the cusp theta is 0. We have taken theta equal to pi. So psi equal to, because it was half pi by 2. Here theta equal to pi. Okay, from vertex, let me check. At vertex theta equal to 0, and at the cusp, because from one cusp, from vertex to the cusp, and then twice of that we have to make. So, and at the cusp theta equal to pi. It means if I put here theta 0 to psi equal to 0, or psi equal to 0 to psi equal to pi by 2, because this is theta pi. If I substitute theta, psi is 0 to pi by 2. This is from vertex to the cusp. From vertex to the cusp, at the cusp theta is pi, and at the vertex theta is 0. So psi will be 0 to pi by 2. That's why I have taken this angle. 4a in terms of sin psi. Okay, the length we already calculated. This is twice of this length. So integration of this will be 4a into sin psi is minus cos psi. Integration. Okay, now limit, if I put 0 to pi by 2, it will give us twice into 4a into minus cos psi pi by 2 is 0. First is minus cos pi by 2, plus in between, because minus plus, and lower limit is cos 0. Cos 0 is 1, which is nothing but 8a. This is, sorry, 4a. I'm sorry, what I'm doing. This is 2 into 4a, that means 8a into 1, because cos 0 is 1 versus 0, or this is 8a into 0 plus minus 0 plus 1, that means 8a. Total length of the cycloid is 8a. This is the length of the whole cycloid. Okay, because from vertex to the cusp, first cusp, this theta was 0 to pi. Okay, and if I make twice of that whole length, then it will give us a complete cycloid. Okay, so from the, this we have traced, the curve we have traced from vertex to the cusp we have taken. So theta is 0 to theta equal to pi, and then it has been converted into psi angle, because we already calculated 4a sin psi was the length of the general length of the arc of the curve. Okay, so in the same way, if we substitute the limits in terms of psi angle, then it is 0 to pi by 2, and twice of that. what is double of that arc, 0 to pi, the 0 to 2 pi total length. If we put 0 to 2 pi total length, that is also there, theta equal 0 to 2 pi. Total length of the curve is 0 to 2 pi length. If I take angle theta 0 to 2 pi, that is 0 to pi. Okay, so that will give us total length. Or we can just take 0 to pi and make twice of that, so half length is calculated. But if we make it twice, then it will give us total length, which is 8a. This is the answer here. The second answer which we have to calculate in question number 9, that what is the total length? Find the length of the complete cycloid. Okay, so that is the question. Now 9th question is finally completed. Now let me take question number 10. Now question number 10 is of what kind? Let me check. Okay, now question number 10. Find the intrinsic equation. Okay, question number 10 here. Find the intrinsic equation of the curve x equal to at square. Okay, this is at square, and y equal to twice at, right? Find the intrinsic equation of this. So we will take general x equal t equal to 0 to t. Okay, so only find the intrinsic equation of the cycloid. So relationship between the length s, length of the arc, and the psi angle. The psi angle is made by the tangent at a point P with a fixed line. Here we take initial line as a fixed line which is parallel to the tangent at the initial point A to P. We have to find out the length, because there is, as I described initially, this is A point here, this is P point here. If I draw tangent at this point, so this psi angle made by this P, okay, tangent at P with the fixed line, this is suppose fixed line OX, let me take. Okay, and if I draw tangent here at A, generally the tangent at A is also parallel to the fixed line. This I described in the beginning. Okay, so this psi angle and the length of AP is S length. This relationship between S and psi is known as length of the intrinsic equation. The relationship between psi angle and length S is known as intrinsic equation of the given curve. So intrinsic equation is found out in this way. Okay, now let me take finally what is the intrinsic equation of this curve here. Okay, this is parametric form again. Let me take solution of this question. Now here we are given x and y in terms of t. It means parametric equations are given. So these are let me take, these are parametric form or parametric equations. So differentiating first and this is, let me take first, this is second here. Differentiating first and the second with respect to t, so we get dx dt is equal to twice at. To t square is differentiated as 2t, but a is multiplied to twice at. This is twice at, and d by dt from this equation is twice a, differentiating with respect to t, so t is 1, twice a only. Therefore, okay, ds upon the length of the arc as length is s here. Okay, we have to calculate, sorry, from t equal to 0 to t equal to t, that we take this general length of the curve. But before that we have to find out ds upon dt. So ds upon dt whole square equal to, this is dx upon dt whole square plus dy upon dt whole square. It will give us, let me substitute the values here. This is twice at, twice a t whole square plus twice a square. That means 4a square we are taking common. In bracket it will be 1 plus t square. Therefore, ds dt equal to twice a under root 1 plus t square. Okay. Therefore, length is, I'll just calculate, but before that, let me find out what is tan psi. And tan of psi angle, we know that this is d by dx, which is in this case d by dt oblique dx dt. It will give us d by dt, we have obtained twice a divided by twice at. This is nothing but 1 upon t here. Try to understand. Tan psi equal to 1 upon t, or t is equal to 1 upon tan psi. That is cot psi. So in place of t, we will substitute cot psi. Here let me write in this case t is equal to cot of psi angle we have obtained. So if we find out the length of the arc and then substitute value of t in terms of cot psi, then we will calculate the intrinsic equation. Let me now find the length. Okay, therefore length of the arc, or intrinsic equation, we will find out length of the arc, or S, length of the arc S, means arc is length or arc equal length is this. This is arc equal length, known as arc equal length. S is arc equal length. So S is equal to, we know, this is 0 to t, limits we have taken 0 to t, general equation. And this is ds dt oblique or into dt. ds dt we have calculated, this twice a. This is 0 to t, we have found out the square root of this also. Sorry, this is twice a, let me take outside, under root 1 plus t square into dt. What is the integration of this? This we know that how to integrate this. Now let me put it here. So 1 plus under root of 1 plus t square is integrated as 1 upon 2t under root 1 plus t square. Try to understand, plus 1 upon 2 into a is 1 here, a square is 1 square, into log of, within bracket, t plus under root 1 plus t square. Take its curly bracket. Okay, and this is here limit 0 to t only. Simply it is the same value we have obtained twice a, because at 0 it will be 0, it will be log 1 is 0. So at 0 everything will be 0, but so 1.2a if I take common, 1.2 if I take outside, it will be 2a upon 2. It is t under root 1 plus t square, plus this is log of t plus under root 1 plus t square. Okay, this is the value of s in terms of t, but t is cot psi, but t is equal to cot of psi angle. If I substitute this to cancel out, this is equal to a, t is here cot psi. Now under root 1 plus cot square psi is cosec square psi. That we will just put here 1 plus cot square psi plus log of cot psi t is plus under root 1 plus cot square psi. Okay, so this will give us finally the answer as, let me write it here. Therefore finally answer is S is equal to a, within bracket it is cot psi into cosec psi plus log of cot psi versus cot psi plus cosec psi. So this is the final answer or intrinsic equation. This is the intrinsic equation. This is the intrinsic equation. Okay, this is the final answer. This is the intrinsic equation. Answer. Intrinsic equation in this case is this. This is question number 10. Okay, so we have now completed question number 10. Now let me talk about 11 question. Question number 11. What does it say? So let me check it. So question number 11 says that find the intrinsic equation of the parabola y square equal to 4ax. It is 11th question. Okay, y square equal to 4ax. We have to find out intrinsic equation of this. Y square equal to 4ax. Okay, and origin being taken at the fixed point. Hence, find the length of the arc measured from the vertex and extremity of the lattice rectum. Okay, so from the vertex to the extremity of the lattice rectum up to extremity of the lattice rectum, that we have to find out the length of the arc. Okay, so let me find out. This is the parabola here. This is the parabola here. Sorry. If I take this properly, this is the parabola here. X-axis, x dash axis, origin or y, and y dash axis. This is the parabola which we have taken. Okay, so from this is the lattice rectum. At this vertex, this is a and twice a. Okay, at this 0, 0, 0 to a or 0 to 2a. If x coordinate we are taking, then it is 0 to a. If we are taking y coordinate, then it is 0 to 2a. So 0 to a if I take, then it is x coordinate. So in terms of x coordinate, let me find out this value. Okay, so question number 11, find the intrinsic equation of the parabola y square equal to 4ax. Okay, so let me differentiate it. Solution. Now let me change the marker. Duster. This is okay. So 2 by d by dx. Differentiating it with respect to this is first equation. Sorry, this is equation number 1. Differentiating first with respect to x. So we get here is twice by d by dx is equal to 4a. Therefore, d by dx equal to 4a upon 2y, or this is 2a upon y, or dx upon dy is equal to dx upon dy is equal to y upon 2a. Just reverse of this, y upon 2a here. This is value of dx dy. Now let us find out ds upon dx. So length of the arc, or length of the arc, or arc over length from vertex to that. Here in this case we will take with respect to y. If I take this is 0 to 2, limits are okay. So y and d upon dx, dy dx if I take, then x we have to take to convert this y into, because y is square root of that x. Okay, or x if I substitute. Okay, x is not given there. Okay, no problem. So length of arc or arc over length is known as arc over length. So ds upon, in this case ds upon dx if I take, or ds upon dy if I take. Okay, or dy upon dx. Okay, that we know about. What is dy and dx? Is tan psi. Tan of psi angle. Let me first find out this. Dy upon dx. Dy upon dx is this value, twice a upon y. So if I put y twice a is equal to 10 psi equal to twice y. Okay. I'm sorry, what I'm calculating and what is given to us. Find the intrinsic equation of the parabola for ax and origin being taken as the fixed point, okay, or from origin, so 0 point, and hence find the length of the arc measured from the vertex and extremity of the lattice rectum. Okay, from vertex to the extremity of the lattice rectum. So 10 psi equal to, is it proper question? Okay, so let me find the intrinsic equation here. For the intrinsic equation in this case, we have to find out that what is the length of the arc here. Okay, so length of the arc of this curve we have to find out. So that means dy upon dx upon dy, if I just calculate into dy, and 0 to by, we will take the general value of this. Okay, in terms of y we will calculate this, and 10 psi, then we will substitute the value of pi in terms of 10 psi. Okay, that will give us the value. Alright. So 10 psi equal to 2a upon y, that we have calculated. Now our y equal to 2a cot psi. In this case, we will replace this y equal to, we have taken, or y equal to here. This implies that y is equal to 2a upon 10 psi. So this is equal to twice a into cot of psi. Simple. This is the value of y. Let me write here. It means in terms of y, we have to calculate this. So 0 to y, I take the limit. Okay, 0 to y, 2a cot. So finally, we will substitute the value of y in terms of this. This is twice a into cot psi. Therefore, length of the arc or arco length. Therefore, arco length, let me write here. Okay, arco length, that is ds dx is equal to square root of 1 plus dx dy whole square, and this is given as 1 plus what is dx upon dy, dx upon dy. From this will be y upon 2a, that means y square upon 4a square. This is, it will give us, if I take 1.4a square out of square root, it will come out as 1.2a, and under the square root it will be y square plus 4a square, or 4a square plus y square. Simple. Okay, so this is now the final value. Okay, therefore arc length, therefore s is equal to limits 0 to, this is y here, are taking 0 to y limits we are taking, and this 1.2a, I have to substitute. Let me first write, this is nothing but ds upon d by, I'm sorry, this is ds upon d by, what I'm writing here, ds upon d by, here we are solving, ds upon d by into d by, I'm sorry, this is ds upon dy with respect to y here. That's why I have written down dx upon dy. I'm sorry, this is ds upon dy. So therefore, ds upon dy, it will give us 0 to y. ds upon dy, this we have calculated. This is 1.2a, let me take out of sign of integration. This is under the square root y square plus 4a square, or 2a whole square plus y square, okay, into dy. It can be integrated as, let me write here. So it will be integrated as s equal to, therefore 1 upon 2 into a, with the bracket it is y upon 2 under the square root. This is 4a square plus y square plus 1.2 into 4a square log of, in bracket it is y plus under root y square plus 4a square. Okay, so 0 to y means y only will come out. Log 1 it will be, sorry, log of 2 it will also come out. I'm sorry. So 0 to y, let me put the limits here. So what it will be? So finally, this value will come out as, now if I put 0 to y0, but it will be twice a then. Okay, twice a, because 4a square is there, so twice a whole square. That means it is twice a here, log of twice a. It will come out as 1.2a. If I take common, it is 1.4a. 1.48 it is y under root y square plus 4a square plus this value is 2a square. Okay, because 4a, 2 I have taken common, so it is 4a square into log of, first will be y square plus 4a square upon 2a. This try to understand when 0, if we put the lower limit with minus sign, so it will be minus log 4a square into log minus sign this y0, but 4a square is equal to 4a square is twice a, so it's twice a from the denominator. Log m minus log n is log m upon n. So this is log of m upon n. Okay, so this is the value. Now if I substitute the value y is twice a cot psi, let me put the value. Putting only then it will be intrinsic equation. Putting y is equal to twice a cot psi to get intrinsic equation. To get intrinsic equation or get an intrinsic equation. To get an intrinsic equation, the relationship must be in psi angle and in s. Therefore, s is equal to, putting in this equation, this is second equation or any second equation that we take. This is s equal to, therefore 1.4a into y is twice a, is y twice a cot psi under the square root. It will be now y is twice a cot psi, so 1 plus cot square psi, twice a again will come out and it will be cosec psi. Try to understand. Why? Because if I take 4a square out of square root, it will come out as twice a. In the square root, it will be 1 plus cot square psi. 1 plus cot square psi is cosec square psi. The square root is cancelled out, so it is cosec psi only. Try to understand. Plus 4a square here also into log of y is again twice a cot psi. Okay, this twice a cot psi plus from this will come out as twice a cosec psi divided by twice a. This twice a cancel out. Okay, so only final value will be then. Very good question. Okay, so this is s equal to, let me write here. Therefore, s is equal to 1.4a, just twice a 4a square. Let me take outside. 4a square will come from this and 4a square from this. It is 4a square will come out. It is cosec psi, cot psi into cosec psi plus only log of twice a cancel out. It is nothing but cot of cot psi plus cosec psi. This is the final answer. 4a. So this is a within bracket cot psi into cosec psi. Try to understand, plus log of cot psi plus cosec psi. Okay, this is final value of intrinsic equation. So intrinsic equation is up to this point. This is the intrinsic equation. This is cot psi plus cosec psi, cot psi plus cosec psi log of this. Okay, so this value is the final answer. So this is the intrinsic equation of question number 11. Answer. S equal to this, cos psi into cosec psi plus log of cot psi plus cosec psi. This is the intrinsic equation of question number 11. Okay, from the vertex and extremity of the lattice and any extremity of the lattice rectum, of the lattice rectum, it is a to twice a undoubtedly. So let me take y here. Y coordinate is twice a undoubtedly. 0 to, this is x and y. If I take the y, I have taken 0 to y. If I replace y by twice a, then can also be changed it. But twice a cannot be changed by. So I have taken y here to change it into cot psi. That's why I have taken general equation 0 to y. Okay, now let me take question number 12. 12th question. What does it say? Now it says, find the intrinsic equation of yq equal to ax square. Nothing is given here. Okay. Now let me take in the same way. I have to find out ds upon dy. Okay, that I will calculate. So intrinsic equation of question number 12. Let me check. Okay, so question number 12 here. Intrinsic equation of that. Okay, now question number 12. Okay, so intrinsic equation of question number 12 is of what kind? Curve is given to us as what kind? Find the intrinsic equation of the curve equation. This is yq is equal to ax square. Ax square, alright. This is the value of the curve. The intrinsic equation of the curve this. So let me solve it. Solution here. Differentiating it with respect to, or differentiating first with respect to x. So we get here, this is 3y square into dy dx. Yq is differentiated 3 into y square, but y is not x, so we have to differentiate it again. That is dy dx equal to twice ax, or d by dx equal to twice ax upon 3y square. 3y square here. Okay, so this is value of dy dx. Just we have taken this as the question. Okay, so 12th question is this. No problem. So d by dx is this. Now let us solve, or dx upon dt, dy, sorry, or dx upon dy. If I reverse it, it will be 3y square upon twice ax. This is the value of dx upon dy. Therefore, arc length of this curve